Okay, so in this video, we're going to solve for mean and using the formula to estimate the mode and the median. So there's a question before us. The table below shows the distribution of heights in a certain school. So this is the distribution table. We have to find the mean. And so if you look at this carefully, this is a grouped data. And so for the mean for a group data, it's a summation of fx over a summation of f. Okay, so it's expedient that we transpose this from a group data to an ungroup data, then we can now solve it. And so we need to find our x. And our x is called the class midpoint or the class mid value. And by so doing, you take any of the limits. So this is the lower class limit, upper class limit. So what you do is that you will add the 2 divided by 2. And so we are 118 plus 126 divided by 2. So we having 122 over here. 127 plus 135 divided by 2. We'll be having 131 here in that order. So the next one is 136 plus 144 divided by 2. Okay. We have a 140 here. We have 145 plus 153 divided by 2, and we have 149. And it applies to all like that. So over here we have 158. Over here will be 167. 172 plus 180 divided by 2, 176. Then the corresponding frequency are 3, 5, 9, 12, 5, 4, 2. Okay. So to find the mean, we need to create a column for f of x. All right, so to find the fx, we will multiply the frequency by the x. So 122 times 3 is 366. 131 times 5 in that order. Times 12 is 1788. 158 times 5 is 790. 167 times 4 is 668. You must make sure you don't make any mistake, because any mistake affects the whole answer. So this gives you 352. So the formula says summation of fs over summation of f. So I need to sum all this fx. So you have 366 plus 655 plus 1260 plus 1788 plus 790 plus 668 plus 352. And that will give me 5,879. We need to sum the frequency of f also, as we can see in the formula. So 3 plus 5 plus 9 plus 12 plus 5 plus 4 plus 2. This gives me 40. So the formula says your summation of fs over summation of f. fx, we have 5879 divided by 40. So when we divide 5879 divided by 40, we are getting 146 0.975. Okay, so we can approximate it to 147 to the nearest whole number. So this is the mean. But if you look at the second question, we have to use the formula. If you have to use the formula, it's different from normal estimation of mode and median. Because if we were to just, just compute find the mean, the mode, if you were to just find the mode, just look at the highest frequency and say it is 12. And their corresponding value is 149. But this time around, we are to use the formula to estimate the mode. We have to use the formula to estimate the mode. And to use the formula to estimate the mode, the formula is this. Mode is equal to L1 plus change in 1 plus change in 2 times C, where our L1 is the lower class boundary, okay? Lower class boundary of the modal class. Our change in 1 is the excess frequency of the modal class over frequency of the next lower class, okay? I will come to that in the explanation. The change in 2 is the excess frequency of the modal class over frequency of the next higher class, okay? Then our C is the size of the modal class. So if you look at it carefully, our modal class is, because the highest frequency here is 12. So our modal class is 145. So the modal class itself is 145 to 153. That's the modal class. And with this class, okay, so the modal class is 145 to 153. So what we can now do is to find a class boundary, because we will need it, because this L1 is the lower class boundary of the modal class. So we need to find a class boundary. And the class boundary is taken from the limits. So if you look at it carefully, if you look at this number here and this number here, that's where you take it from the limit. So you look at the upper class limit, which is 126, and the lower class limit of the next one, which is 127. You subtract it, okay? Whatever value you get, you divide by 2. So 127 minus 126 will give me 1. 1 divided by 2, which is constant, the 2 is constant, you give it 0.5. Then you now subtract it, that 2, you subtract it from the lower class boundary and add it to the upper class boundary. Subtract, you add, subtract, you add, in that order. And so having said that, let's move. So if I subtract 0.5 from 118, I'm going to get 117.5 to 126.5. So now this one becomes 126.5 to 135.5 in that order. So filling all the class boundary, this is what we had. Okay, let me quickly clean this side so that we can solve the mode now. Now I think we are cool to go to solving the mode. Okay, we are cool to go to solving the mode. We are cool to go to solving the mode. All right, so what we're going to do now is to find we need to find the mode. And to find the mode, we say the mode is your L1 plus changing one plus changing 2 times your C. Your C is the class size. So our L1 is the lower class boundary of the modal class. So look at the modal class, we said it was this, right? We said the modal class is this. This is the mode. So this is the modal class, 145 to 153. What it is corresponding the lower limit, the lower class boundary. So the lower class boundary gives me 144.5. 144.5. So we put that one here, 144.5. Then the changing one we say is the excess frequency of the modal class over the frequency of the next lower class. So you just look at the value you have over here. This is the mode. So this is your reference point now. So 12 minus 9 gives you the changing one. Okay. And 12 minus 9 gives us 3. The same changing one is 3 here. Plus changing 2 is 12 minus this 5 because it's the excess frequency of the modal class over the next higher class. So minus this 5. So we have 5 here. Then the class size, if you look at the class boundary over here, okay, you see where the difference gives you the class size. The difference gives you the what? The class size. So the difference is 9. When you take 153.5, okay, minus 144.5, you will get 9. So now we can easily compute for the mode. So you have 3 divided by 8 times 9. And this will give 144.5. And so okay, so the change in 2, I was saying 12 minus 5. Sorry, 12 minus 5 is 7. 12 minus 5 is 7. Thank you. So here is 7, 7. So 3 divided by 7. So now the denominator becomes 10. So 3 divided by 10 times 9. 3 divided by 10 times 9 gives us 2.7. So we will be having 144.5 plus 2.7. And that will give you 147.2 centimeters. So this is the mode, okay, using the formula, 147.2. So it's still between the same number, okay? All right, so that's how we compute for the mode. Now let's move on to the median. Okay. Okay, now we move on to the median. This is the formula for the median. If you are to use the formula to estimate the median, this is the formula. So we have median equal to L1, okay, plus half capital N minus summation of F1 over F of M times C. And your L1 is the lower class boundary of the median class. The N is the total frequency. The summation of F1 simply means the sum of all the frequency below the median class, okay? Then the FM is the frequency of the median class. Then the C is the size of the median class. So to solve this using the formula, I just want to put all of them on the one page so that we can understand and relate it quickly. So the median is your L1 half n minus summation of F1 times C all over Fn. So the median, you look at the median now. Now we sum all the frequencies. And after summing all the frequencies, we got 40. Half of 40, okay? Because the median is half summation of F. So half of 40, we are getting 20. So you sum the frequency and see where you can locate 20. So 3 plus 5, we are getting 8, okay? 8 plus 9, we are getting 17. 17 plus 12, we are getting 29. So you realize that within this position over here, where the median can be detected, we are looking for the lower class boundary of the median class. So if you look at it carefully, we are still here. So this is the lower class boundary. So this is the class boundary. So the lower class boundary is now this 144.5. I hope it is clear. So we put 144.5 over here, plus half. The n is a summation, the total frequency, as you can see here. So the total frequency is 40 minus summation of F1. We say it's the sum of all the frequencies below the median class. So if this is the median class, okay, you need to sum all this before you get to the median class, which is this. Before you come to that median class, which is here, you need to sum all the frequency and see before you get there and see what you get. So 3 plus 5 is 8. 8 plus 9 is 17. So that also gives us 17 divided by the FM is the frequency of the median class. So the frequency of the median class, as we said, with the data is from here, is 12. And my C, which I've done already when we're tackling the mode, is 9. So the median will be equal to 144.5 plus half of 40 is 20 minus 17 divided by 12 times your 9. So you have 144.5 plus, this will give you 3 over 12. And 3 over 12, because 20 minus 17 is 3. 3 divided by 12 is 1 over 4. So you have 1 over 4 times 9. And 1 over 4 times 9 is the same as 9 divided by 4, which will give me 2.25. So eventually we have 144.5 plus 2.25. Okay. So we'll be getting 146.75 centimeters to be the median. So that's how we solve questions like this. Yes, we need to do all of them on one page so that we can easily, see the distribution table as we are working alongside. I hope it is clear. All right, so see you in the next video. I wanted to pause and, make sure you like, share, and subscribe, and make sure you follow it step by step. We'll watch it and you will be fine. All right, see you in the next video.